We are KBG Technologies. Allow us to introduce
Avinash Kisun, our system designer, database analysis and programmer. Iran Ghani, our database analysis, designer and thinker. Varun Budram, our research analysis, data collection and system tester.
This project aims to safeguard all members of the University of the West Indies due to the recent altercations that took place over the past year.
Some of these altercations being sexual assault and armed robberies. KBG has arrived at a solution which uses a fingerprint scanner to allow authorized entry onto the campus as opposed to the current system in which there is no formal recognition as to who is entering the campus.
The requirements for this project is categorized into functional and non-functional requirements. Functional requirements are the services that the system should provide and how the system should react to particular inputs and how the system should behave to particular situations. Non-functional requirements are the constraints on services or functions offered by the system.
As seen from the diagram, this is a general overview of the system that we intend to implement. The user requests access to the campus, which they are then required to scan their fingerprints, which is then used to search the database for an existing match to verify that they are indeed a member of the university. An approval message or denial message is sent to the security officer and access is then either granted or denied.
In this use case diagram, there are four primary actors: the user, the fingerprint scanner, administration, and the security personnel. There are two secondary actors, the database and the email service. The actors interact with the system through the following processes. Registration. In order for a user to be a member of the university, they need to be registered, where their fingerprints are recorded and stored on the database. Notification. Before a user is permitted entrance to the campus, the user is required to scan their fingerprints at the entry points and a notification is then sent by the scanner to administration to verify the user's credentials. Authentication. After the database is searched for an existing match, once a match is confirmed, the security officer is sent an approval message. Else, if there is no existing match, they are sent a denial message. Guest entry. Once an approval message is displayed, the security officer allows entrance to the campus. Else, if a denial message is displayed, the user is given two options: to either exit the campus or provide their personal information and receive a temporary ID card which must be returned upon exiting the campus. Alerts. Alerts are triggered via the user in an emergency situation. This is done through the use of an app via the user's mobile phone. Once an alert is activated, the user location is sent to the campus security, which will be displayed on their monitors. The user scenarios that were ranked the two highest were authentication and guest entry. In authentication, the use case type is project requirements. The priority for this use case is high. The primary actors in this use case is the user and the fingerprint scanners. The secondary actor are the administrator and the security personnel. In the guest entry, the use case type is business requirements. The priority is also high. The primary actors are the user and security personnel, whereas the secondary actor is the administrator. These are the use cases for the above scenarios that were previously explained: authentication and guest entry.
A class diagrams used for describing structure and behavior in the use cases. It also provides a conceptual model of the system in terms of entities and their relationships. A class consists of attributes, which is a significant piece of data containing values that describe each instance of that class, such as a user ID and username. There are also methods which allow you to specify any behavioral feature of a class, such as add user and update user. There are relationships between all classes and the user classes. The first type of relationship we will describe is inheritance. This is done by drawing open arrows we are saying that the child class inherits all of the attributes and methods of the parent class, the class the arrow is pointing to. Another relationship is composition, which is denoted by a shaded diamond arrowhead, which is when a child object is not able to exist without its parent object. This can be seen as authentication cannot occur without a user. The last relationship is aggregation, which is denoted by an open or unshaded diamond head arrow. And this is when a child class can exist without its parent class. An example of this class would be the email service class, which can exist on its own without having an interaction with the user. Two types of test cases used in this project are integration testing and unit testing. Integration testing involves the combined testing of more than one classes. Unit testing, as the name suggests, is a process of testing individual unit classes. The two tables shown depict two test cases under the unit testing scheme. The first one shows the testing of entering a user's address. This test is shown as a fail to demonstrate how the system will behave if an incorrect data is inputted into it. The second unit test involves the input of a user ID and alert location to ensure that alerts aspect of the system works as expected. In the slide shown, this is a form of integration testing. The two tables shown depict the interaction between more than one class. In the first table, the input of user ID and also user fingerprint is requested from the user, and this is sent from the fingerprint terminal to the database in administration to verify the information. In the second table, under the integration testing method, shows yet another alert feature of the system. As can be seen in the remarks section of the table, this case hints on the interaction of the user class and the security class once a user is in a panic situation.
Moving on to risk management. As seen on the table, there are various risks that can be associated with the project. For example, key staff that are ill and unavailable at critical times can have a serious effect on the business operations of the university, which may occur at a moderate pace. The strategy implemented here is a contingency plan where shadowing personnel is introduced and used. The rate of defect repairs of scanners may be underestimated. This can affect the product, which can be dealt with by replacing potential defective components with reliable ones. Lack of accuracy of capturing full data. This affects the operation of the university and defeats the purpose of the implementation of the scanners, which can result in catastrophic events as there is no way to verify any user. If more than one user trying to obtain verification from different entry points simultaneously, this can lead to the database not processing the transactions, as it cannot process many transactions per second as expected. This affects the operations of the campus and can be resolved by avoiding the situation by purchasing a higher performance database. If the fingerprint scanner rejects an authorized member or accepts an unauthorized member, the probability of this occurring is low, but in the instance that it does occur, it will result in catastrophic events, as unauthorized members will gain entry to the campus that can pose a threat and danger to other university members. This can be avoided by replacing potential defective components with reliable components. If a user that is given a temporary ID card, they can still pose a threat to the safety to the university members, as access is still granted to this user. This risk is catastrophic in the instance where harm is brought to a member of the campus. This can be avoided by having security personnel be present at all times around the campus.
So now we move on to the cost estimation, whereby we explain all the techniques and stuff that we use to estimate the cost of the software project in question. Now, continuing along the lines of our estimation stuff, we want to specify and justify the technique we used. So we have decided to go with constructive cost model version 2, otherwise called the COCOMO 2 model, as our estimation technique because it allows us to make decisions that involve a development effort. We can set a budget and a schedule as a basis of planning and control. We can decide on or negotiate trade-offs among factors of software cost, schedule, functionality, performance, or quality. We can also make decisions for software cost and risk management. This model helps us to decide which parts of the system can be developed, reused, leased, or purchased. And it can also help us to make decisions on what parts of the system should be modified, phased out, outsourced, and so forth. With this model, we can implement mixed investment strategies to improve the capability of the system. And we can also decide on how we will be implementing the process improvement strategy. Now moving into the breakdown of the project, it is pretty clear that the hardware has some very unique specifications, as we will be working with the entrances at the south gate, the north gate, the administration gate, as well as the eastern gate by Dag Auditorium. And as such, each computer system to be used with this software will be implemented with a fingerprint scanner, a PC, and a digital camera, specifications of which you can see in the current slide. And then, of course, there is the additional fixed costs and overhead costs that went towards this project. So we did 22,400 TT dollars for the cost of the hardware alone, which would have implemented with fingerprint scanners. And then software costs came up to 2,900 TT for the biometric software development kit, which will be used to develop the software for the system. Overhead costs included maintenance, which ended up at $0 annually, as well as labor costs, which came up to about 20 TT dollars an hour, which, given a 40-hour work week, is $100 for the week, which will equate to 3,200 TT every month for labor alone. And as you can see by the results that we have gotten through using the model, our budget has come up to just over 250,000 TT dollars, with a work week of 15.6 months and a high effort of about 79 months approximately. And that's pretty much valid by the staffing profile graph that you can see on the results as well.
In conclusion, we at KBG Technologies would like to thank you for taking the time to view our presentation. We place a high tolerance on customer satisfaction, and we hope you choose us to complete your project.